Hello and welcome back to Guillotine 18th Century Chemist Theater. What I thought I'd do is I'd give you a real quick Lewis dot practice problem using double bonds. So we're going to take a look at formaldehyde. So our friends are back here. So we're going to run through a practice problem here. Again, we'll go through the rules real quick here. Remember that you are going to count up the total number of valence electrons available. You're going to draw a rough representation of the structure. You're going to connect everything using single bonds, consuming 2 electrons apiece. Then you're going to sprinkle unshared pairs around to get everybody to a full valence shell. And then you're going to check your work. So what we're going to focus on today is showing you what happens when you have, if you need a double bond. One of the things people do is people usually jump the gun on double bonds. They try to use them too soon. Don't use them until you've consumed and run out of all your electrons and you still don't have it done. All right, so formaldehyde, you've got 1 carbon, 2 hydrogens, and 1 oxygen. And so that's going to be 4 electrons from carbon, 1 from each of the hydrogens, and 6 from the oxygen. So we have 12 electrons to play with here. The basic structure, again, put carbon in the middle. And then in the case of formaldehyde, you end up with hydrogens on each side and then an oxygen. And again, carbon's going to try to make 4 bonds, so giving it 3 bonds makes sense. It wouldn't make as much sense to throw the hydrogen on the other side of the oxygen because then carbon's only going to be reacting with 2 elements. So carbon's going to try to react with as many as possible. So we're going to put down single bonds here. That's going to consume 6 of my electrons, 2, 4, 6. Now, we have 6 electrons left. So the astute among you realize that we don't have enough electrons because I need 8 unshared pairs. Well, I need 4 unshared pairs, 8 electrons, and I've only got 6 electrons left. Now, you can put the electrons wherever you want. If you want to give them to oxygen, great. If you want to give 2 to carbon and the rest to oxygen, great. You're going to run into the same problem either way. So what I did is I went ahead and gave 2 to carbon, and I gave 4 to oxygen. Again, I leave it as an activity to you to show that if you had given oxygen all 6, you still would have had the same problem because now carbon would not have been happy. But in the scenario we drew now, in the iteration we drew, hydrogen's happy, it's got 2. Hydrogen's happy, it's got 2. Carbon's happy because it's got 6 from bonds and 2 from an unshared pair, which means oxygen is unhappy. It's got 2 from a bond and 4 unshared, which means oxygen still needs 2 more electrons and we're all out. And so so oxygen is kind of in a little bit of a sticky wicket because it doesn't have enough electrons. But this is going to work out just fine because carbon does have an unshared pair. And so oxygen's kind of like, hey, I'm kind of bummed out. I don't have enough electrons. And carbon's like, well, I was planning to keep these electrons to myself, but I don't lose what I share. And so what carbon can do is carbon can swing in its unshared pair and share it too. Oxygen, you could say, well, why can't oxygen do that? Well, because if oxygen shares, it's not getting more electrons. And then that puts 10 electrons around carbon. So that's not going to work out at all. And so what we do is, all we're going to do is we'll erase the unshared pair off carbon, and then we'll slide it in and make a double bond. Now carbon still has 8, and now if you count around oxygen, it also has 8. And so now everybody's happy. And so that's how you do double bonds. Save it, don't do it until you need to do it, and then go ahead and just slide in some unshared pairs and get everybody happy. Notice that, again, oxygen's making 2 bonds, hooray, and carbon's making 4, hooray. And each hydrogen, of course, is making 1, double hooray. And so that's it. I just wanted to show you one little a problem showing you double bonds. When you're ready, the next lesson will go into 3 other more advanced topics for the challenge student among you. Thanks for watching, and have a great day.